Okay, this video we're going to start a brand new series. Last time we were making a demo on how to use all the different components of SDL to make a window, to draw background to the window, to make a sprite that moves around, load sound effects, to play music. This time we're going to make a simple game with it. We're going to restructure it to make it structured better for playing a game, but we're going to be using all of those techniques and all the functions that we learned and all the methods to doing different things that we learned in the last series. So this series we're making Don't Eat the Yellow Snow. So the first thing you want to do is grab the GitHub Programming Rainbows Yellow Snow C SDL2. So we're going to be in SDL2 and C in this one again. So we're going to want GitHub. We're going to clone this. So you're gonna need Git, you're gonna need make, you're gonna need C installed, you're gonna need all the SDL2 stuff installed, SDL2, SDL2 mixer, SDL2 image, SDL2 TTF, the libraries and the header files. All right. And if you're working with VS Code, you can just open VS Code up inside of this new folder that we have that was created when we cloned the repository called Yellow Snow C SDL2. Okay, so we have a couple things going on here. Just real quick, we have the stuff. The reason why we need to clone this repository is we need the font, and we need the images that we're going to use. We need the music. We need the sounds. And if you just want to build the actual finished program, it's in source. That's the whole program running. Or if you want to follow along with the video, whatever video that you're coming into, you can just grab the source from the last video. Say you start at video 3 and you missed video 1 and 2, you can just go into the video 2 source, or for this case, it would be video 1, and you can copy that source over the source in the header files, and you can just put them in the source directory, or you can tell it to compile directly from whatever directory you want to. It'll put the binary in the top level directory that we'll see it. We'll see that. We'll just do it real quick. So this is going to be the actual program that we're making. We're not going to be using make today, but I'm just going to use make right now just to show the program working. This is actually compiling it straight from source right now, and it should run it. And this is the game running. So you can collect all the yellow snow, or the white snow, sorry. But you don't want to ever get the yellow snow. If you get the yellow snow, the game stops. If you press space, it'll reset it. And if you press escape, it'll close. So this video is all going to be about talking about the structure that we want our game to be, and setting up everything that we need, all the boilerplate stuff to get our window up and running and everything else. So at the end of this video, we're going to have a black screen, but we're going to have a different structure than we had in our last. We're going to have multiple files. So like I said, the source code for this video is actually in the video 1 file, but we're not going to use that because we're going to be creating all of this. So if we come over here, I'm going to delete everything that's in the source folder. So this folder over here, this source folder here, the final game, we're going to work in there for this video 1. So in future, you can pull the source code from whatever video you want. I'm going to work in here. I'm just going to remove this folder, everything in it. We don't need it. And then I'm going to recreate this folder, just so it's an empty folder. So now we have an empty folder. We're going to start making some files. Let me just close these other ones so you don't think. So we're in here. We're going to be making some files. We're going to need main.c and main.h. And this is going to be we're going to be structuring this kind of like modules. Main is going to have our main function in it, and the only thing that it's going to be responsible for is launching and closing the game and cleaning up. That it's doing nothing else. There's going to be another module that's going to be controlling the game, and then the player will have its own module. The snow will have its own module. The scoring, the text will have its own module. the FPS, we have an FPS counter, and we're going to be using delta time and everything else. That's going to have its own module. So for today, we're going to be doing the main, the game, and initialization, which is actually just augmenting the game. But I didn't want the game source code to be so long, so I put it in its own kind of module just to help game out. So main is going to be pretty simple. Like I said, and also we're going to be creating these things on the heap. So we're going to talk about that. But main, let's just start with main. It's going to be a pretty simple thing. We're going to let main H bring in everything that we need for the game that's just general in the whole game. So main C is not going to be doing a lot except pulling in main H. Since this is a local header file that we're pulling in, it's in double quotations. It's not in the angle brackets. And we're going to do the main function. I am going to put void in here because we're going to, when we do make our make file, we're going to be very strict with this C compiler, and it's going to complain about any oddities whatsoever. It's going to make our code safer and less likely for us to make mistakes. So I'm going to be filling this with void. And we are returning. I'm going to get it right one of these times. I'm going to be using this exit success. Okay, and we will show this off real quick. So right here. So this is a C++ reference, but it's the same for C. Again, these are just preprocessor macros defined in stdlib. They are going to be helping us just tell it, the program, whether it succeeded or not, because using 0 or 1, I can't guarantee that it's 0, 1 for every system out there. So instead of that, I'm going to use exit success and exit failure. So you can look this up. This is a macro, but it's just for us to say, did the program exit good or bad? And let's do the hello world real quick. And I am going to add the into the main header what we need for this hello world and everything else. So let's do the new line character. There we go. Okay, that looks pretty good just for that. Let's get to the header file so it'll stop complaining. So the header file, we need to put our guards on, the defined guards. So we're going to do the if and def, and we're going to call it main H. Then the end if. Okay. So I want that in. So we're going to be using this. You've seen this if you've done C before, but this is so that the header file only gets included one time in the source code. Even if it's referenced many times, it's going to say, hey, if this kind of handle has been defined, we're going to ignore everything. But if it hasn't, we're going to define it now and do everything inside of it. So it's kind of makes it happen just one time. And we want to include, of course, we're working with SDL2, so we want to include that. We're going to be working with true and false, so we're going to bring in standard bool, standard IO for the printf and the fprintf, and standard lib for other things that we're going to be doing. Now these are going to be using the angle brackets because they're system ones, they're not local. So let's go. And if you don't know what I'm doing with all this stuff, like, and you haven't watched the prior series goes through all of this in detail, and that would be very good to start there watching that. Again, my SDL2 is installed into the SDL2 folder, which is a standard thing to do on Linux. So that's where mine is. Okay, so those are the header files we need. We are going to define a couple other kind of game-wide things here, like the size of the screen, um, the SDL flags, the title of the screen. We'll do that in a minute. We'll come back to that. So now that we've done this, this should be better. We are using, I don't know why it's complaining about that. Okay, let's just make sure that this compiles. Okay. Because we are working in a subfolder. And let's call this the actual name is going to be, I think it's it. Yeah, we'll just call it Yellow Snow for right now, because we'll get to that later. Okay, so we got Hello World. We know it's working. So again, we're going to be structuring this. So this main is only going to be just starting off game, initializing the game kind of, what do you want to call it, module. It's going to be a structure with functions and everything else. So it's going to be creating that structure, and then it's going to be running the run thing inside of it. That's the only thing main's going to do, and then checking to see if those have failed or not. So what we're going to do to find out, well, we're going to be running two functions. One is going to be called game new, and the other one's going to be game run. So let's make those real quick. I'm going to make a couple more files, and this one's going to be just called game.c, game.h. .c. So game.h is going to be exactly like the main.h right here. But it's going to actually be pulling in main.h. So all my kind of submodules, since I have included all these SDL and bool and IO and lib, since I've included them here in main.h, I'm just going to include main.h into all my other header includes. So the game.h is going to just include main.h is what's going to happen. So let's do that. We got game.h. I'm going to say we got to put the includes on here. Game.h. I don't want that. Okay. So what we're going to do is we're going to include the local main.h here. And we will make some functions. So we are going to just prototype these two functions real quick. They are both going to be returning a bool, whether they failed or succeeded. We'll call it game new. And these are going to be bringing in struct, so we're going to create that struct real fast. And this is a pattern I'm going to be doing in all of these modules, like player, player, for the snowflake, for the score, and the FPS, I'm going to be doing this exact same thing for all of them. And we're gonna store the event. This is where we're gonna store our pointer for our window, our render, and we're actually gonna store the event here just so it's all in one place. The event's not really important. It's just a union kept on the stack, but the window and the render, we are going to be managing those. So we will get to that as well. Let me just show you we're going to bounce around a little bit. Where is the poll event? It needs a type of SDL event. So that we're going to be holding our event in a type of SDL event. So SDL event, and we'll just call it event. And then we are going to make our 2 pointers for the window and for the render. Okay, that's what's going to be in our, we just have to make this code not complain, we need to set this up first. And so we're going to be pulling this into these functions. Now, the new function, since I'm going to be affecting the pointer from inside of the game new function, I'm actually going to send in a pointer to a pointer instead of just sending every other time I'm going to be sending in a pointer. But if I'm actually affecting the pointer itself, I'm going to send in a pointer to a pointer. So normally I have this game struct, right? And I'm going to make a pointer so I can pass this game struct around. That's fine. If I'm ever changing anything inside of the game struct itself, I'm just passing a pointer to the game struct. But if I need to pass a pointer, if I need to affect the actual pointer itself, as in allocating memory to it or nulling it later, I'm going to be sending in a pointer to a pointer. So it's always going to be a pointer except when it's a pointer to a pointer. So we'll call this struct game, and I'm going to follow kind of the naming scheme that Go uses, where they just use inside of the object, they just used a single letter for what it is. So instead of calling it game, I'm just going to call it G, because I know inside of my game module, G is going to refer to itself, to game itself. So that's why there's a pointer to a pointer. We also need a function to free the game, and we're going to be sending a pointer to a pointer on that one as well, but this one is void. And for game run, we're going to be doing the standard pointer. I'm just calling them G just because I'm too lazy to write game, and it's pretty well understandable. So that's our basic header file. So I'm pulling in everything that was given in main H. That gives us access to standard bool, standard IO, standard lib, and SDL2. So since I've pulled that in there already, I'm including it here as well, and then that's just bringing it all in for us. And then game C will have access to all of that as well. What did I do here? Oh, I know what I did. Yeah, I didn't need that there at all. Okay. So let's get back to yeah, we had to do that so we could work with main again. So what I want to do is I want main to create the game struct. It's going to tell game to make it, but I want to do it from main. And then I need to know if that failed, and I also need to know if running the game failed. And either way, I need to clean up, but I also want to exit with it failed or not failed. So the main function is where it exits. It doesn't exit anywhere else in the program. So if anything fails anywhere in the game, it's going to collapse down through all the different function calls all the way back down to main, and then it's going to clean up and it's going to exit. It's going to exit either cleanly or not cleanly. So what we're going to do here is we're going to actually make the pointer for game. The pointer is going to be passed in. That's why we need that pointer to pointer. And then we are going to be checking whether each of those failed, and we're going to be exiting accordingly, and we're going to be cleaning up. So let's do that. And we can just, we'll call it game here because we're not inside of the game module. But when we're inside of it, we'll just call it G. Oh, we need to include up here. We actually don't even need to include main.h up here because we're not using it. But we do need to include game.h. So we need to include game.h. That gets us access to that. And okay, so right here we have our, this is the other thing that we're going to be doing in this game. We are, just like in the prior video series, we are not going to be declaring any variables. Everything's going to be initialized. So we're declaring nothing to garbage data. Everything's initialized. And that also goes with the malloc. We're not going to be using malloc because malloc gives this heap, but it's got garbage data inside of it, and then it's going to return us a pointer. Instead, we're going to be using calloc, and calloc is going to zero out everything in it, and everything's basically initialized to 0 or null or whatever the equivalent of nothing is. And so we're going to be using that. So here's our thing, and what we want to do is we want to know if both the initialization and the running of the game fails. Either one of them, it doesn't matter. So we're going to put them in an if statement. Remember, they're both returning a bool, and the bool that they're going to return is going to be true if it fails and false if it succeeds. So game new, and we have to get the address of game. We already have game as a pointer up here, but we need a pointer to a pointer, so we need the address of game. That's for the new function. And then I'm going to use the logical OR and do the same thing with the run. So it's going to run game new first and then game run. And if either one of those fails, this if statement's going to be triggered. And for game run, we just need the pointer. So it's just, we're not getting the address of the pointer. We're just sending the pointer in itself. And what we're going to do here is we're going to clean up the game, and then we're going to exit badly. And we are sending in the address of a pointer for this one too. For just these two kind of functions, to create and to free, we need the address of it because we're actually affecting the pointer. Then we are going to return be correct. Exit failure. So we're making our pointer. We're going to use the new function, which is going to be setting up our struct and everything else. And then we're going to be running the game. And if either one of those fails, we are cleaning up and we are exiting. Now, if it doesn't fail, we are still cleaning up. We're just going to exit with the better code. Okay, so that is going to be our whole main. That's our whole main source code right there. That's all we need. We're handing it off to game, and we're just seeing if it failed or not, and we're telling game to clean up. So that is everything for that. Okay, so let's switch back over to game now. I'm just going to close this because we're not going to be doing anything else with it. So we have game H and game C. So we're going to be doing this exact same thing that I'm going to show you right here for all of our other modules, the way that we're going to create this um, kind of this module or whatever with the struct with the functions and everything else going on in it. The struct itself is in game H, so we need to include that. And game H includes main H, so we have access to all that stuff. Sorry, needs to be in double parentheses. Okay, and we're not going to bring that in yet. So this, we're going to make our new, and then we'll make our right away our free. We kind of need them both. So this returns a bool. And remember, this is a pointer to a pointer. We're going to call it game. Oh, I know why I did that. Okay. We're going to call it game here, but right away I'm going to switch to G so it's easier to type. Because what's going to happen is we're going to be dereferencing this game over and over again, and I don't want to do that. So right away I'm going to just dereference it. Yeah. So I'm going to change it back in the header file real quick. This right here, when I'm messing with the pointers, I'm going to call it game. Because right away what's going to happen is I'm going to make another variable just called G that I can work with that is going to be the dereferenced version of game. It'll make sense here in a second. So again, we're passing in this address to a pointer. And the reason why we're doing that, the whole reason why we need to do that is because we need to calloc. We need to create this on the heap. We need to put the allocation on the heap, and we need a pointer returned. So that is going to be game. So calloc is in sorry. So calloc is just like malloc, except for it actually has another parameter. You can put a number in for, say, if you want to do an array, it would be how many items. I'm always going to be just doing one because I just need the struct on the heap, but I only need one of them. I'm not actually doing an array, but I do want it all zeroed out. So using calloc is going to help me do this. But this first number that you would use for how many, we're going to put the size of the array in here, and then this first number would be if you had multiples in sequence, you had an array of those, how many you would want, and we don't need that. We just need one of them. So this is going to be one for us, and this is going to be the size of the struct, and that's going to allocate the heap. It's going to allocate the memory on the heap, and it's going to return a pointer to us. But that memory is going to be zeroed out, so we're going to use that. We're not going to be using malloc, so it's always going to be calloc, and you can read more about it here or other places. So calloc, and like I said, we're just going to have one of them, and this is going to be the size of the struct game. Okay, so that actually is allocating our struct right there on the heap. So now we need to know, did this fail or not? So we're going to test it, and we'll just see if it equals null. Because this has the dereference in front of it, yeah, I'm just going to use the null. So it's I don't want to set it to null. I want to check its equality. And we'll be using their fprint. Fprintf, setting it to standard error. Error in calloc of new game. We'll give a new line character for that. And we do not need to get any more information on the error. So we are returning straight out of this function if we didn't get our, anything assigned to us. So we're going to return right away, return true. And that means something went wrong. Okay, so that'll come right out of the function. We'll return true. Let's make sure we didn't use, yeah, I spelled that wrong. Okay, and we need to come out of this with our default, just so, yeah, if everything returns well from it. So this is, we're going to be using this over and over again, this exact same setup here for player, for the player sprite, for the snow, for all of the snow actually, and the score and FPS. This idea that we're creating it inside, we're calicking it, and now when we need to use it a bunch, we can just, I'm just going to make a dereferenced version of this to use easily right away. That I'll call G. So this says I need a pointer to a game struct, but that pointer is the dereferenced game, which is a pointer to a game struct. So when I dereference it, this is a pointer, and I'm just storing it now here. So it's going to be G is going to be my pointer, game is going to be my pointer to pointer. I don't really need the pointer to pointer anymore in here, but I did need it for this calloc up here because we are changing the pointer inside this struct. So that does need to happen. And what this function is actually going to just be doing for this video is we're going to be initializing the game. That means initializing SDL and creating the window and the render. So that is going to be in another function. We haven't created yet. Initialize G, and we are just seeing if that fails or not. And if it does, we're going to return true. So that is going to be it for that function. We are just literally making, we're making the struct allocated on the heap, and we're going to be initializing basically the game, which is the SDL stuff for this video. So let's work on it's going to complain that this doesn't exist here. Yeah, we could just prototype it up here. So we could say initialize is going to be a bool as well. And it's going to be struct game, and it's just going to be G. So we can just put that up there for right now so it stops complaining. And let's just do the free real quick. I'm going to be a little bit stricter in the way that I free in this one. So this is void, and it's game free. And again, this is a pointer to a pointer on this one because we are affecting the actual pointer. Okay, and we already know that we are going to be starting up SDL, and we're going to be creating the render in the window. So let's just remove those here. And these are all going to be null because of the way that we're using calloc above. So before they are populated, they're all going to be null. There's going to be no garbage data in these. So right away, I am going to do the whole struct pointer to G thing. Just to, so I don't have to write this over and over again because I'm lazy. And that's going to be because we are going to be affecting the actual pointer, so we do need that pointer to pointer, but we just don't need it in all the other things that we're doing. So I won't need to dereference it over and over again. Otherwise, it'll be quite complicated to write it. I'm just going to, using my head, I know that I'm going to be initializing SDL. I know that I'm going to be creating a window, and I know I'm going to be creating a render, so I'm going to reverse those right here for the cleanup. And these are all up here. We've covered these in the prior videos, so if you don't know exactly what I'm doing here, you really want to check out the first video with the SDL and C, making the demo application. We are going to be, well, we'll show it as we go through it. I'm just cleaning up the cleaning up the memory in this one right here. So it's destroy SDL. Yeah, that is actually destroy window, destroy render, and back over here, SDL quit. Those are the ones I'm going to be using. And it's going to be G render. And what I'm going to also do is I'm going to set the render pointer to null now that we've freed it. This is probably not necessary, but just for best practices, I'm just going to do this. No, the same thing. Okay. Now that we've done that, now we're going to shut down SDL. Okay. I know we haven't created any of these things yet. I'm just kind of doing it in reverse order. Sorry about that. So now we've basically cleaned up all the memory and shut down SDL, but I actually want to deallocate the memory for the game struct itself now. So that is why I needed to hand in the pointer to a pointer. So what we're going to do is we're going to use free, and we're freeing G. Okay, and G is going to equal null. And now I actually want to, I didn't need to send in the pointer to pointer for any of this. Well, yeah, I did. So, but I actually want to make the game pointer itself that we passed in null as well. So I'm actually freeing the memory that was allocated for this, and I'm making sure the pointer is set to null, and I'm making sure this pointer is set to null too, just in case. So it's just kind of being extremely safe about not letting any freed pointers be accessed. So I'm setting everything to null that I'm no longer using. So now that we've kind of destroyed all the stuff that we were going to allocate, now let's actually allocate that stuff. And what I'm going to do is put the game initialization in its own file, because this game file is going to get quite big. Let's close this real quick. So right now it's very small. It's a very small file, but this game file is going to be handling the running of the game. So this whole initialization right here, that's going to start growing and getting bigger and bigger. And I'm going to put that in its own file, even though it's still kind of, when I'm thinking about the game module, it is its own module, but it's kind of helper to game. So what I'm going to do here is I'm going to take this, and I'm just cutting it, so you can cut it, copy it, or however you want to do it. And I'm going to include this, and I'm going to call it initialize.h. So I'm going to call that initialize.h. It's going to complain because that doesn't exist yet. That's why I'm kind of jumping around in all these different orders, because it's kind of like the chicken and the egg, who's first. So we need to make that and initialize game, or sorry, initialize.c. So we need the initialize C and H, and we'll go into the H right away, and we've got to put the header guards on. I always spell this wrong, so I just want to check. Hopefully I'm spelling that right. Okay, and we're going to bring in the main. Okay, so we have the one function that we need the prototype to, that we copied earlier or cut. So this is going to be the function that we're dealing with here, and that is going to be it for this header file. So let's get into actually initializing SDL and creating those things. So right away we need to include the header file for initialize. Initialize, and then we're going to make this function. So if you still have it copied, you can just paste it again. Apparently I don't, so I'll write it out. It's game initialize. I don't know what I'm doing. Okay. So the first thing we want to do is initialize SDL. And we're going to use the SDL flags that I didn't create yet. It's just going to be everything. And SDL initialize is something that fails. It fails 0 on success or an error code. So we're going to set a constant for everything. I'm just going to use everything here. I'm going to set a constant for that so it can be changed in the main.h header if you ever want to change it. And I'm just going to be looking for 0 on success is what I'm going to be looking for. So I'm just going to use the if statement. So we'll do that. SDL flags, and we'll do a fprintf. And this one will be error initializing SDL, and then we're actually going to get the SDL error. We'll do a space, and we'll do our format. What's it called? Where you do %s for a string, and our string will be SDL get error. Again, this was all explained in the other videos that I did. So if this fails, I want to know, I'm going to send this to standard error as my output, and I'm going to send it, I'm going to make this message myself, and then I'm going to add the string to this message with a new line character. I'm going to, so this string is going to be there. This is a placeholder for the string that's going to be returned out of what error actually happened. So I know what was the actual problem. And then I'm going to return true, because returning true means that this function failed. So that will initialize SDL, and then we can create a window, and we have access to our game on G, so it'll be G window. We haven't kind of set these up. Let's go back and let's set up this SDL flags and the window title and the window height and width. Let's all set that in our main.h file real quick. We're pulling in everywhere, so we don't get all the errors. So I'm going to set some global variables here, and it's going to be like the title, the width and the height, and the SDL flags. So we'll just do the pound define, and we'll call it SDL flags. We already used this. That's why we're getting an error message. We didn't set it. So right here, I'm going to put, I could put SDL init video. The problem with this is when I use the more strict compiling and then I start doing what is it, sanitization, the memory checker. When I do this, it gives me false positives if I just do this. Now, if I set two flags like this, and then I do like SDL init audio, right? This again is this is a binary. So this number, which is just an encoded binary for how to turn on video, and this or for which a switch, and this one is for an audio one. If I binary add them two together, I'm going to get the number that's going to be, that is going to be the binary equivalent of turning them both on. So, but anyway, the sanitizer checker that I use later on for the video to see if I have memory leaks. For some reason, if I just use video, it goes crazy. If I use video and audio, it doesn't. I think it's just really flaky. I'm not sure what's going on with that, but I'm just gonna initialize everything. But again, you can use this global to play around with it and try different things. I think that's right. Everything is that init everything. Yeah. So you can combine these or just do everything. So I'm just going to do everything for simplicity. Now we want our kind of window title, width, and height. So we'll just call this window title. And remember not to put any semicolons at the end of these defines. Don't worry about the colors here. That is just something either with the it's just trying to show me colors that yours may or may not do the same thing. It's not going to affect anything. That's just kind of a helper thing for when you're writing code. So we'll go width and we'll do 800. This game with the pictures and stuff has been set up for this. You can do other things, but for this, we're going to use 800 by 600. Okay, 800, 600. That's everything we need there. So we're going to save that. Now we can use these without it complaining in the other file here. So click type. Oh, because we are not returning true yet. Or we're not returning false. Okay, so let's keep going with this. So right now we're creating the window. Again, I'm just glossing over these things really quickly because, again, if you watched the last series, I went into depth. But we have the window. We are looking for a title, a string. We're looking for the X, the Y. We're going to use set window pause center for both of those. Then we're going to do our pound defines that we just made for width and height, and we aren't setting anything for the flags here. So that's what we're going to be doing. Create window. So this is our string first, right? So we can just put our window title. I think that's right. And then we can put our the X and the Y is going to be the SDL. Let me just double check what it says. SDL window pause centered. Is it centered? Yep. And then we have window width, window height, and 0. Okay. And now we're going to do the same thing with our check. I'm just going to grab this up here. And the way we're going to be checking it is to see if the window is still null. Let's say not G window. So not G window. And we are going to say error creating window. Error creating window. And we're going to still get the SDL error, and we're still going to return true. Okay. So again, we are going to just move right on to making the next one. We're going to make the renderer, which is over here. We've already set up the destroying of the window. So the renderer, we're just passing in the window to it. The index is going to be -1. The flags are going to be 0. That's right. Oh, I actually put SDL render accelerated. Don't know if it matters. I think if you don't put anything, it automatically. I think it automatically chooses. Where is it? Render flags. So the render is a software fallback. The render uses hardware acceleration. Present sync. Okay. So I'm in my project. I'm using render accelerated. So we'll just use that. I think it can just be 0 though. Equals SDL create render. We're going to pass in the window to it. And then we are passing in -1. And that's for the index. And we're going to be putting in this guy. Okay, so let's just see what these errors are real quick. I know what I've done. I'm being so boneheaded here. The reason why I can't pull any of this game information in, I was thinking I need to bring in game up here, but it's my header file. It is wrong. It's this needs to be game.main. So yeah. Because it's telling me it's not being used, which is right, and it doesn't know what the game struct is because it's in game.h. Yeah. Okay. So window, and I'm spelling this wrong. Cool. Okay. I must have spelled it wrong in the other file. Let's go check main H real quick. There, I flipped them. I do that quite often. Okay, so we're back on track. So this is we got our initializing SDL. We're initializing the window. We're checking the window, and now we are initializing the render. We haven't checked the in case that one failed yet. So let's do that right here. I'm just reusing that code above, but we need to change this to render and creating, say, a render. We'll say capital W on this one. So we're checking that. Error, render, yes. Returning true. And if nothing else fails, we're returning false out of it. And that is going to be that for the initialization. So this is kind of a little spider web going on here, but yeah. So main is launching game. Game is creating itself. Let's go over here. Game is creating itself. And then it's, after it's allocated its own memory, it's initializing itself here, which is going into our initializer that initializes everything. Hope that makes sense. So we're not actually running game yet, but we have initialized everything. So if we go back to game C, or sorry, main C, we haven't set up game run yet, but we could check if this is just working. So the way that we're going to do multiple files is pretty much the same as the other one. We are going to just put those multiple C files. The next video, we're going to break down how to use a makefile, and we're going to have a quite extensive makefile for this. That's going to be very generic, that you can use in all kind of medium-sized projects. But in this one, we're just going to use GCC from the command line. So we need to deal with a couple files here. We got source main. We also have source game and source initialize. And then we're doing the output. Oh, sorry. Yeah, we're doing the output of yellow snow, and we can put the SDL lib there. That should work too. SDL2. Okay. And I know it wasn't exciting, nothing happened, but it actually initialized and closed down. We can check that out real quick by going into game, where it's cleaning everything up, and we could give ourselves a message here. Just to verify that it did start up and then shut down. All clean. And now we could cause an error real quick before we move on. So here, let's just fake an error by letting it fail there, on the render. So we're not going to get an actual error message out from SDL get error, because an error didn't actually occur, but we're kind of simulating one here by letting it error if anything is set for render, which something will be set if it's correct. So we're just reversing it. Okay, so we should get an error here. There we go. We got our error, but we didn't actually get an error message because a real error didn't actually occur yet. And we have all clean. And I'm just going to remove those now. And we're going to make the window open and work this time. So the cleanup. And initialization. Fix that. So we do know all the code's working, even though it wasn't opening anything. So now what we need to do is we need to make the game run function. So we got game new, game free. Below it, let's do our game run. And this one's going to return a bool. And we'll just say G. Okay, so what this one needs to do is it's going to be doing our main game loop. So this is going to be dealing with it's going to have our while loop basically. We can do that. While, and I'm just going to put while true, because true is always true. Because I'm not going to be shutting this loop down that way ever. So it's just always going to be running. And now we're going to be, we can do the thing where we set the render. So let's just do that first before this. Let's just show a window happening. We'll do SDL, and we're going to do a render clear. This is down here somewhere. Render clear. It's just taking the render, and we don't care if it succeeds or not, because this is something that's going to happen in our game loop 60 times a second. It's not going to be a big deal. We care about loading of stuff. We care about anything we're allocating on the heap, anything game objects we need to load in. We don't care if the render didn't clear one frame. We're also going to present the render. This is going to give us our actual window, everything to look at. It's going to be black. It's also return. This one's void. It's not returning anything. And we're going to be using SDL delay. We'll do the 5-second delay first to see our window, and then we'll set up our game loop. So clear render, and we need to pass in the render. And this time it is game render. We'll go SDL render present. Render again. And then we'll do an SDL delay. And this takes in milliseconds, so 5,000 is 5 seconds. So this window is going to open. It's going to stay open for 5 seconds. It's not going to accept any inputs on you telling it to close. So if you try to tell it to close, it's just going to say that it's not responding. And then it's going to close after 5 seconds no matter what. Okay, so, okay. Mess this up right here. This should be a pointer right there. And I accidentally put it in the wrong spot. And I'm going to return false. That's our default good case, is false. So this is going to open a window, stay open for 5 seconds, and then it's going to close. Well, that didn't work. Oh, the reason why it didn't work is because we're not calling this function. So we've made this function, but we need to call it because we deleted it in main a second ago. So it needs to be right up here. And this is going to let both of these functions run, and if either one of them fails, it's going to cause the failure close. And this one is just game, because game is already a pointer. And there is our window. And if you look up here, let's do it again. It says, don't eat the yellow snow. We will be adding an icon, but it will be in video 3. So on that, let's set up the game loop that checks to see if the window needs to be closed and runs it at roughly 60 times a second. Game C. So now we will be putting this into a loop. So while true, and these will be tabbed in. Okay, so that will just now be running in a loop, and the loop will pause for 5 seconds every time. So we're going to change this to 16 because that's about 16 milliseconds is roughly 60 times a second. Later on in the videos, we will be making a proper FPS setup with delta time and everything. But right now we'll just use 16 milliseconds. So now what we want to do is check events, close events. So we're going to use the SDL pull event right here. And we already have an event variable in our game struct. So we're going to be using that one. We're going to be populating that and using that. We're going to use this function, and that's gonna every time we call it, it's going to get the next queue and populate our event with whatever event that was until it's run out. So that will be a while loop again. And we'll go pull event. Now we already have this event in our game, but we actually, since we are changing the event inside of its function, we need to send in the address of it. So that's the address of our event that's in the okay. So as before, we're going to do a switch statement. Again, I went into detail about this in the prior series, so I'm just going quickly over all of this stuff. We're just going to check the event type to see if it's a quit event, and if it's a quit event, we're going to just return false, and that's going to allow the code to clean itself up correctly. So we're going to switch. Event and the type. That's what we're checking on the switch statement. And the case that we're looking for is SDL, and this is all capital, quit. I think this is an enum. This might be an enum under the hood. I'm not quite sure, actually. SDL quit. And the only thing we need to do for this, everything is already in place. So all we need to do is say return false. And return false, that's going to break out of this run. It's going to return back to main, and main is going to clean up and say, yeah, it returned good, and now we're cleaning up. So we don't have to do anything else. We need to put our break in, and then we need to put in a default case with a break. Okay. Now this is going to let us close the window if a close event has happened. If you told the window to close, if you press the X or on the top right or top left, depending on what window manager you have. I don't have one at all, so I actually press Super or Shift C to close things. But whatever way that you tell it to close and shut down correctly, this is now going to accept that event and shut down now. But let's add the escape key as another event that we will check. So we're switching on the type. Let's add in another case for that. And we will check key down. This is an event from going up to down, not is it still down. Key down. Okay, so, and if that is it, we actually want to check which key. And again, I've gone into detail about this in the prior videos. So we're going to switch on this one. And we're going to be checking the G. We're going to be checking the event, and then the key sim, and scan code. I think that's all spelled right. Yep. Okay. And what we're looking for is the SDL scan code escape. And this is all in the pull events. You have to dive a bit deep into these, but you're going to end up with like, let's see. Here we are, SDL scan codes. This is all on the libsdl.org Winky page, and these are all the different scan codes. The only one we care about right now is escape, but pretty much if you just type in SDL scan code and then whatever letter that you think that you want, what's on the keyboard in a capital letter, you're probably going to be safe. So scan code escape. So if that happened, we're going to do the exact same thing. We're just going to return false, and we'll put our break. Even though this break is not actually going to be seen, we're still doing it. And we're going to put in default. Okay. So this is running through all our each iteration of this loop. It's grabbing if it has a queue of 10 events, it's going to populate my event union with that first event and then do all the checks, and then it's going to populate the union with the second event, and it's going to do it 10 times if there's 10 events on the queue. Then it's going to run the rest of the code and any new events that have come in now, because the queue will be empty. And then while this is running, if a new event happens, it's going to be in the queue now. So when it comes back up here, it's going to run through all those new events. So that's pretty straightforward. This kind of thing, you're always going to have this in CSDL. Even in Pygame, you have something similar. So now we should have a window that stays open indefinitely and then closes whenever we press escape, or however that you close a window in your system. Okay, so I'm going to press escape. There we go. And I'm going to tell it to close, and there we go. So that is going to be it for this video. I just want to walk through again. I want you to kind of understand the reason why this is done the way it is. Let's go to game. So game is running. Main. Main is making this pointer, and then we're passing in the reference of that pointer and populating it, and then we're using it. If anything happens bad while we're in this function, it's going to return true, and then it's going to know that this has failed, and we're going to get an exit failure. If it returns as false, it's going to skip any of this, and it's going to clean up the code and exit successfully. So no matter what happens, no matter if a function is calling a function it's all going to collapse down. So if it's true, it's going to, or if it's false, it's going to keep on its merry way. But if it's ever true, you're going to see this. Watch. So this function is called by main calling game new, and then inside of game new calls game initialize. So inside of this function, if this function fails, well, it was called by game new. So let's look at game new. Game new, when it called it, it's checking if it failed too, and it's returning the same thing. So no matter how deep we get in functions or wherever we're at in the code, if it ever fails with true, it's being caught and being sent back down. So if this fails and it's got a true, it's returning true. So that means this function is jumping right back out to main, and when this catches true, it's doing the normal cleanup in that. So no matter what, our game is always going to shut down successfully if we want, or if something happened wherever it's at, it's going to close itself down. Now, the way that it can close itself down, no matter what, is in game. We'll go into cleanup real quick. These things don't matter if they were populated or not, because when we invoke the oh, I should probably put a check on this actually. I am missing one check on this. Yeah, I am missing actually one thing here when I think about it, but we'll cover that in a second. So say the game, if 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 uh if it's made on this on the heap already, it's all null. So if it doesn't matter if any of these things were created, these functions will return immediately if they see null. So the fact that we used calloc instead of malloc to allocate this stuff means that all this stuff is zeroed out ahead of time. Okay. So the thing that I didn't catch is if the very first calloc failed. If the very first calloc failed, how are we returning? We're returning true from this. So if game is null, so let's simulate that real quick. I think this is a bug in my program, basically. So I'm not, right? So I'm not callocing this, and I think we may have a bad time on this. Yeah. Aaron calloc. Yeah. The Aaron calloc, that's all good. The problem occurs here, this segfault, because I'm actually trying to access members of something that doesn't exist. So I just thought of that right now. That's because I before the video I actually changed my main file slightly, so the way that it goes. But basically, I need to wrap this whole thing in an if statement. So if it's not null, I want to do all this stuff. That should fix it, but let's just double check. And let's put a let's just put a print statement in here so we'll know later if it's checking or not. So what I want to see is I want to see this not being triggered right now with the error that we just set up where the game never gets allocated. I want to see this not being triggered. I want to see it saying that an error occurred and it closing the program, but this nothing in here and no segfault. That's what I want to see. That's what I'm hoping will happen. Why am I still here? Sorry, I think this is backwards. Okay, there we go. Now, if I remove this right here, I should now see that this is being run. So basically, I can't get to the G renderer and G window if G doesn't exist. If G is null, then it has no member called render or window. That's what my bug was right there. So basically, I need to see is G real first? If it's real, then we're going to start cleaning things. Now we got members. But if it's not, if it never got allocated up here, it doesn't even exist. So yeah. So right now with the bug out of place, now when I close, I should see this print message happening to know that we're still correctly running. and we'll check for memory leaks later. And it cleaned. Okay, so yeah, I did have my main setup totally differently before, so because of the way that I changed it, I wouldn't be cleaning up if this failed. Basically, if this thing failed right away, I wouldn't be cleaning up, and I didn't think about it before the video. So I had a little bug there, but it looks like we caught it. We will be, when we use the make file, we're going to be really strict with all the compiler rules. So we're going to we're going to catch a lot of silly mistakes, a lot of things that you might not realize you're doing. It's going to be checking for all kinds of stuff. It's going to be really quite strict. But yeah, so I hope you understand the logic of the way that this game is going to be put together. This is all boilerplate in this video, but it's so that everything shuts down correctly or runs correctly. In the next video, we're going to be talking about the makefile, and then after that, we're going to be doing backgrounds and the icon for the window icon and all that. But that will be it for this video, and thanks.